Seems like it changed, but anyway, okay. So greetings, YouTube. Beautiful Mind Pfeiffer here. So we're moving on. We're continuing with Chapter 5. Today we're going to be looking into Section 5.4, trigonometric functions of any angles. Let's go ahead and be ready for Exam 1 next Thursday over Chapter 5. All right, so we have to do the best we can with Chapter 5. So I know we're in 5.4 right now. Idealistically, I might probably make some videos, some lectures outside of class for you all to watch, because we just don't have a lot of class time like what I'm used to having, okay? So we'll do the best we can. So now we're going to be looking, let me see. Yeah, so these are some of the objectives. Let's just kind of get into it. Okay. I think we said, we mentioned some of this stuff last time, right? Sine of theta. Okay, let me see. What did we say last time? Opposite over hypotenuse, right? So if we have ordered pair, if we have a point plotted in ordered pair, right, then we can make a right triangle with that ordered pair, right? So like if you have the x comma y, you can make a right triangle with the origin and an ordered pair. And so the sine of that theta should be still opposite over hypotenuse. That's what the r is, right? So that's a circle of any radius. So r can be any radius. Let's just kind of see it in action. To me, this is easier seen in action. So let's see. So here it says, find the exact value of each of the 6 trig functions of a positive angle theta if 12 over 12 and down 5 is a point on the terminal side. Okay. So let me think about this. Do I need some? Can I write it here? Okay. So yeah, we can use that. Let's kind of do like this. Let's duplicate. And here, let's get rid of all of this stuff. Okay. Okay. And we'll just do black for now. Let's see, is that x squared plus y squared equals r squared? Okay, so if we have, really quickly, let's just kind of look at it like this. So say this is the origin. If we go right 12 and, I don't know who that is. I thought I turned that off. If we go right 12 and down 5, we'll have a point here, right? So just saying that's the origin, and then we have this, and so we can make a right triangle, something of this nature, right? Where this will be our, this might be a little off with the theta, but that's essentially the idea, right? So I know it's supposed to be positive. We're going to kind of just go with this for right now. So then the horizontal displacement is what? Based on, it gives us our x value. This would be our y. And so we can talk about any circle of whatever this radius is. We're going to call this r, right? So then what formula can we immediately use with this kind of image going on? Yeah, Pythagorean Theorem, right? So Pythagorean Theorem, we have what? So we should be able to say that x squared plus y squared equals r squared, right? I think this is okay so far. So if we plug in what we have, so what we could say, what? 12 squared plus negative 5 squared should give us our r squared. So then that's 144 plus 25 should be r squared. So then r would be what? The square root, what is that? 169? Which is what? 13. Normally when we do square root, we do plus or minus, but we're kind of forcing the distance to be positive here. So we're just going to take the positive result here. So then our r should be 13. So let's fill these in. So then our x was 12. This was negative 5. And this was 13. Okay. Find the exact values of the 6 trig functions. Okay, so we should have everything that we need. So let's do like this. So then sine of theta will be what?
5 over 13.
Negative 5, right? So then negative 5 over 13. Cosine of theta would be what? Mm-hmm. Okay, 12 over 13. Sine, cosine, and then what? Tan of theta.
Negative 5 over 13.
Try again.
Wait, which one?
Tan.
Oh, I'm sorry. It's going to be, it's a 12 over negative, wait. Yeah, 12 over negative 5.
I think you got it reversed.
Negative
TOA, right? Opposite over adjacent.
opposite of
So negative 5 over 12. What's the reciprocal of sine? Cosecant. Theta. What's that going to be?
13 over negative 5.
What's the
How
reciprocal?
come it's negative 13?
Okay, so negative 13 over 5 is actually the same as 13 over negative 5, which is the same as negative 13 over 5. These all mean the exact same thing. Okay, what's the reciprocal of cosine? Secant, just secant. Mm-hmm. Secant theta, 13 over 12. Reciprocal of tan is cotan, tan, right? Theta, and that's going to be what?
Negative 12.
Okay, these should be our results. Any questions here? Okay, let's see how do we do. So for this point, we have a is 12, b is negative 5. So that's like our x is 12, our y is negative 5. So then we can use Pythagorean Theorem. So then we get the radius. So then I think we got all these results. Go ahead.
So let's say we get another problem where it gives us an ordered pair and variables that they use, we have no values are x and y.
Oh, variables instead of numbers?
You know how to try before we knew exactly what they were, we did x, y, and r, right? What if it wasn't x and y, a, b, j?
Well, if it's an ordered pair, those are just labels, right? So I know they used A and B, it's just a label. But if it's an ordered pair, that means you're moving from the origin to that point. It's still the same basic shape. Does that make sense?
The first letter's going to be x.
Yeah, as long as your x is going horizontal, your y is going vertical, right? Okay, so that's what they're using here. Find the exact values of the 6 trig functions of these. Okay. I'm probably not going to do all of. Well, I think they're quick. I think these are quick. Okay, so blue is fine with me for right now. So say we're doing part A. Say we're doing sine of 0 degrees. Anybody know sine of 0? Yeah, sine of 0 is 0. I'll give you some explanation as to, like in my mind, there are two different ways I'm doing this. I know I'm looking at the graph of sine, which we haven't talked about yet. So just kind of do the best you can for right now. Sine of 0 is 0. What's cosine of 0?
0?
Mm-mm. Yeah, I got to think about. Yeah, it's 1, right? I'll give some backstory. I'll give some explanation as to how I'm getting those, generating those numbers a little bit later on. Sine, cosine. Let me see. Tan is 0. So then, okay. So tan is what over what again? What's another one way that we describe tan? Opposite over adjacent is fine, but then also we could do what?
Sine over cosine.
Mm-hmm. So if we said 0 over 1. Okay. I think I have the reason I'm pausing because I'm thinking of an explanation for sine and cosine. So say we're on a unit circle. Say we consider a circle of radius 1, right? Let's kind of draw a picture. So just really quickly, say we have our xy plane and we consider a circle of radius 1, right? And so, but if we're going to do 0 degrees, that means we're talking about this here. Is that okay? All right. So what's the ordered pair if we're on a unit circle, on a circle of radius 1? What's that ordered pair for that point?
0.
Not the origin. 1, 0, right? So that order pair is 1, 0, right? So imagine this. I'm just trying to give some backstory and explanation as to why these are. Suppose this was our theta, right? Suppose that run is 1. Suppose that height is 0. What would be the radius? What would be the hypotenuse? 1 squared plus 0 squared is what? Is 1, and then the square root of 1 is 1, right? So these would be the components of that triangle if it had a height, right? So then now, even though this is physically impossible, but this is just for seeing how we're generating these numbers. Now, suppose we did sine of that theta. Sine is what again? From Sol Katoa? So if we did opposite over hypotenuse, what result do we get? 0, right? If we did cosine of this angle, what result do we get? Because it's 1, cosine is adjacent over hypotenuse, so we get 1 over 1, which is just 1. Once we have sine and cosine, we can do everything else. Does that make sense? So that's a little bit of backstory. That's not what I originally wanted to say, but that's why I kept pausing. I was like, I think we can use something that we've already talked about to explain why sine is 0, 0, and cosine is 0 is 1. Does that make sense? So tan is sine over cosine. 0 over 1 is 0, right? Okay, so I'm going to get rid of that image on the right because I kind of need that space. Yeah, I'm just going to erase it. Do y'all need that image on the right? That was just to kind of see where those numbers are coming from. Okay, I'm going to get rid of this. Okay. So now, what's the reciprocal of sine? Cosecant. Okay. Cosecant. So then, so if 0 is 0 over 1, when we go to flip it, what kind of result do we get? What's 1 over 0? What is that?
0.
That's undefined, right? So let's do this really quickly. 0 over some number. This is okay. This is okay. So this is equal to 0. But some number, but some number over 0, that's a KO. You want to knock that out. This is undefined. All right? Is that okay? So when we go to take the reciprocal of 0, the result again is, so 1 over is undefined. Yeah. So the result is undefined. So this one we could say does not exist. What's the reciprocal of cosine? Secant of 0. What is that going to be? What's the reciprocal of 1?
The reciprocal of 1?
1, right? Okay. And then what's the reciprocal of tan? What does not exist?
Because it's 0.
What does not exist? I didn't say.
It would be
What's the reciprocal of tan called?
Oh, it's called
Cotan, yeah. So cotan of 0 again is equal to, or which is undefined, right? You gave me the result without any kind of label. I wasn't sure what that was referring to. You see what I'm saying? So when we go to flip 0, those are all undefined. These are the results there. Let's go ahead and move on to B. Sine of 90 degrees. You all know sine of 90? So we'll actually know a lot of this stuff off the rip. I'm just going to kind of jump to some answers. Anybody know the sine of 90 degrees? Okay, let's just do that quick triangle again. So, I mean, this is just an introduction. I typically don't do it the way I'm about to show. So, say we had our triangle again, right? If we're at 90 degrees, say we're on a unit circle, a radius 1. If we're at 90, we're up here, right? It's up here. So, what's this ordered pair up here? If it has a radius of 1, what's this ordered pair?
1 and
0, 1, right? So this would be the point 0, 1, right? And this is the origin, 0, 0. Say this is our theta, say this is a 90. I know this is not proper. Let me think about it. So the x is 0, so this would be 0, this would be 1, and then the radius is 1. So now, if this were the case, right, what would be sine of this theta? Yes, right? So sine of 90 is 1. Again, this isn't really proper, that green that I have, but I'm just doing that so you all can kind of generate the numbers initially. Tell me about cosine of this angle, or cosine of 90.
Oh,
1 over
cosine.
1 over 1. Oh wait, no, it'll be 0 over 1.
Which is,
Undefined. No, it's 0.
because 0 over some number, that's okay, right? Okay, so look, what do we notice? What do we notice? Let's go back to the first one. When we had 0 degrees, we were at the point 1 comma 0. So the 1, is that our x or is that our y? If we're at 1, 0.
1, 0.
Is that our x?
Is our x.
1 is our x, right? So when we go back to part A, which between sine and cosine, which one was also 1? That's our x, right? And then what was our y when we were at 1 comma 0? What was our y value?
0.
We were at 0. Does the sine correspond to the y value?
Yeah.
Yeah, okay. Does that also hold for the second one? Cosine, does that match our which variable, x or y? Cosine, does that match the x or the y? That cosine matches
Wait,
the,
for which one?
for part B. Because B, we said now we're doing 0 comma 1. Does cosine match the x or the y? Does sine match the x or the y? So can you see the pattern between cosine and sine versus x and y?
Yes. Okay.
Cosine essentially is x,
And
and sine is essentially y, right? Okay, so that's a base thing that I want you to kind of get from that discussion. Again, this triangle is not, we typically don't do that, but I was just doing that so you can generate the results with what we've talked about. We have much faster ways, much more sophisticated ways to just quickly get to it, look at it, and we'll know. But for right now, it should be clear that the cosine corresponds with the x. Essentially, cosine is our x and sine is our y. That's a good place to start for right now. So now that we have sine and cosine, what's the next one? Tan of 90 degrees.
Is that going to also be 1?
They changed this. Tan is what over what again? Sine over cosine.
No, it's undefined.
Right? Some number over 0, that's a KO. Undefined. So we're going to go like this. Our time is definitely getting away from us, but that is okay.
Oh, really?
It's okay. It goes by fast. This class is super short, but it's okay. Tan of 90, we said 1 over 0, so this one does not exist or is undefined. Okay. What's the reciprocal of sine? Cosecant. Okay, cosecant 90. So what's the reciprocal of 1 is... which is just 1, okay. What's the reciprocal of cosine? Secant. Say it. Secant. Say it again. Secant. Everybody. Secant. Secant. Yeah, it's just, I don't know how to, the only way you get it is through repetition. Secant, and then once you have secant, cosecant naturally follows. It's just secant, cosecant, sine, cosine, tangent, cotangent. It's really only 3 words, and then the alternatives, you put co in front of it, right? So secant, sine, and tangent. Those are the 3. And then put the co in front. Okay. We did cosecant, so then the next one is secant of 90. Secant of 90. Okay. So we're taking the reciprocal of what? What's the reciprocal? What was cosine of 90? So what's the reciprocal of 0? 0 is already 0 over 1. When we flip it, 1 over 0, undefined. Is that okay? Does not exist. Or undefined. And then cotangent is the reciprocal of what? Tan. How do we get that? How do we get that does not exist for tan? So tan of 90 was 1 over 0, right? So then that means cotan is going to be what? Which is that okay? 0 over some number that's okay. So that's going to be 0. Okay. So that was B. Let's do C. Go ahead. Hang tight. Just let me try to wrap this up, okay? So now, if this is 0 degrees, here's 90. Say we're still on the unit circle, a circle of radius 1, and we go 180 degrees. What's the ordered pair that we're considering now? -1, 0, right? So remember, we just said that the cosine is our x and the sine is our y. If we're at negative 1, 0, tell me about sine of 180 degrees.
Sine.
Is that our x or is that our y?
No, it's our y.
That's our y. If we're at negative 1, 0, what's the sine of 180?
Negative 1, 0.
So,
0.
0, right? So sine of 180 is 0. Cosine of 180 is what?
1, negative 1.
Negative 1. Okay, I think this is okay. Tan of 180. Okay, sine over cosine, so that looks like 0. Cosecant of 180. So flip the 0 is undefined. I keep drawing my equal symbols and I don't need them. So we're going to say undefined or does not exist. It's the same kind of deal. Then we have secant of 180. Negative 1 sounds good. And then cotan of 180 does not exist. Okay, let's do this last one and then we'll entertain questions. 270. Where are we? What order pair are we considering if we consider the unit circle? Where are we? So here's 0, 90, 180, 0, negative 1. Is that right? So we're considering 0, negative 1. So tell me about sine of 270.
Negative 1.
Okay, negative 1 sounds good. Tell me about cosine of 270. Okay, tell me about tan of 270.
It's going to be undefined.
Does not exist. Okay. What's the next one? Cosecant.
Cosecant. Oh my God.
It's okay. Cosecant. What's the result there?
It's going to be.
Cosecant is a reciprocal.
It's 0.
Negative 1, right?
Negative 1.
All right. And then what's the next one? Secant. 270. Secant is a reciprocal of. So this one's going to be undefined because we're flipping the 0. And then cotan of 270 is 0. Okay, let's entertain some questions. I know there was a question. Where's my attendance? And you had a question?
Yeah, I think I got it now, but I was just questioning just like
Thank you.
halfway inside.
Do you know what you all know where your classmates are? No, it's okay. Go ahead. I'm sorry.
But yeah, I'm starting to get it.
It's okay.
You just look at the degrees and you just picture it on the board.
Yeah, for right now. Yeah.
Can it always be like 0 or 1?
No, this is just the start. All right. Okay. So the quiz that I handed out, just take it home and bring it on Monday. Okay. First thing. Tuesday. First thing on Tuesday. The quizzes or the exam? Well, the exam, there's a high probability that. So you wanna have your homework notebook. That's why I kept saying as many details as possible, right? Because sometimes I do that, sometimes I don't. But the best thing is you want to have your completed homework notebook with as many details as you can. Bring it in the day of the exam. So next week is an exam. But I might change it up. I might do something like a formula sheet instead of your entire notes. I might do like, okay, 1 sheet of paper, and you can write whatever you want on it. All right? I think I'd rather do that because that way you still have to kind of process a bit. All right? So we can go ahead and make that. You still want to bring in your homework notebook the day of the exam, but let's go ahead and limit it to just a sheet of paper. So you can put anything that you want on that sheet of paper. Also, you're going to be on the lookout for a study guide and all that kind of stuff. Okay? Okay. Okay. Because, in the past, I've let students use their notes. And you still get a spread or a spectrum. You have some students that don't need it and they do fine. Some students that use it and do fine. You have some students that use their notes and still can't get it. And then you have the other category where students don't have it and need it and they do bad. All those different scenarios. So the notes are inconsequential. They don't really matter. What matters is if you're practicing on the while, right?
Yes, I started them. Why are we in here?
Uh-oh. You have a question about the homework?
Yes.
Let me finish out this section. When I finish this section, we'll entertain it. Okay. So go ahead and pull it up. Okay, I'm going to move forward. I'm watching the clock. I want to take a few more minutes on this one, not too much more time. What's she doing? Oh, she just liked it, yeah. I'm going to take a few more minutes on this and then keep going. Let me see how many slides we're talking. Yeah, we got a good ways to go. All right. Did we get those results? Okay, so they chose any point on the terminal side. They chose one that was 2 from the origin. And then they essentially did the same thing that we did, right? As far as the explanation, as far as how to generate the initial numbers. So we're going to kind of let that be. So they're kind of doing a similar discussion the way we did. Going to let that be for right now. So again, I have a quick way of committing this to memory. You can kind of look at this on your own. Really, the next section, I think, blows it out of the water, in my opinion. When we start talking about the unit circle, I have a quick way to do a lot of this stuff. Okay, so we'll come back to that. So the next objective is to use coterminal angles to find the exact values of trig functions. Okay, so two angles in standard position are said to be coterminal if they have the same terminal side. So when our angles are in standard position, they all have the same initial side, a ray on the positive x-axis. And then coterminal means that last side, the terminal side, they have the same angle. So like in the first example, is angle A positive or negative in the first one? Because is A rotating clockwise or counterclockwise? Counter. So is that positive or negative? That's positive. If it's angle B, positive or negative? B is negative. But these are what we call coterminal angles. Is angle A in the second one positive or negative? How many? Notice that angle B did at least one full what? One full rotation, so it's larger than 360, but these are considered coterminal angles, even though they're the same angle essentially. They have the same start and finish, right? Okay. So find the exact values of these. So notice the first one is 390. How much more? We did a complete revolution. How much more than one revolution did we do? Right? So how did you get that 30? No. How did you get the number 30?
Because 360 is 1 full revolution.
Right. So you said the 390 minus 360, right? So if we're doing part A, so the coterminal angle, so the result for this one should be the same as the result for, if we said 390 minus 360 is what, 30? So it should be the same as cosine of 30 degrees. Anybody remember from last time what cosine of 30 was? I'm eager to give you my shortcut, but I'm really trying to wait till the next one. So I'm going to use my shortcut in my head. Let me see, 30, 1, 2, 3. That's our x. I got it. Root 3 over 2, is that right? Okay. So we'll go with that. That's what I got when I did my shortcut. I will give you the shortcut when we get to the next section. You're going to love it. It's fantastic. I love it. If you don't love it, at least one of these, at least this shortcut has some love from somewhere. Exact values of each of the following. I think that's it for that one, right? All right. I think that's it for part A. So once you get the coterminal angle. Okay. So 420 is the same as what? What's the coterminal angle there? So this is the same as tan of, is it 80? 60, right? It should be the same as tan of 60 degrees. So 60, let me see, 1, 2, 3. Okay, anybody got that result, tan of 60? I need an exact result. Okay, what's sine of 60 degrees? Okay, sine of 60 is root 3 over 2. What's cosine of 60? 1/2. So tan of 60 is, let's write it out. So tan of 60 is going to be sine of 60 over cosine of 60. We just said that's root 3 over 2 divided by 1/2. What's the result there? Just the square root of 3. How can we check this with a calculator? We're going to check these in a calculator in just a moment. Let's go ahead and do C. I'm a fan of converting these to degrees first, right? Let's convert 9 pi over 4. We could work radians. I think I already know what the answer is, but let's convert it to degrees. I do better with degrees than radians. I can see it a little bit better. So let's convert 9 pi over 4. What's the conversion again? Times 180 over pi. This is gone. 90, 45. So whatever 45 times. Hey Siri, what's 45 times 9?
45 times 9 is 405.
Okay, right? Is that okay? So C should be the same as sine of 405 degrees, but that's at least what? So what's the difference? That's 45, right? If we say 45 minus 360, we get 45. So this should actually be the same as sine of 45 degrees. What's sine of 45? Root 2 over 2. Okay. So now let's check these in our calculator really quickly. We got 390. Help me to remember the originals, right? So I'm going to flip over to my calculator because I can't have these showing at the same time unless I do something different. Let's go like this. Let's open up the trusty dusty rusty. Okay, what was the first one? What are the first? Cosine of 390 degrees. So if we're going to use a calculator, the first thing that we need to do is make sure that it's what? If we're doing cosine of 390 degrees, it needs to be in degrees, right? Okay. So let's go to mode. Let's go down and change it to degrees. And let's quit. And so the first one asks us to do what again? Cosine of 390 degrees. So now we're good to go. Now what did we get as an answer? So then when I hit enter here, what kind of answer should we get? Some kind of decimal, right? So now when we hit it, we got this, right? But when we did it, we said it's what? The square root of 3 over 2, and we should get the what? Same decimal. See how that checks out? That's how we would check that. So we still need to know how to do it by hand, but we can confirm our result by using the calculator. What was the second one? 420. Tangent of 420. What result did we get? We got just the square root of 3. So if we just did the square root of 3, we get the same thing. What was the last one? 9. So what do we need to do with the calculator first? Put it in radians. So we hit mode. Let's go down to radians. We said what? Sine. 9. My pi is above the caret over here. 9 pi over 4. What result did we get? Okay, so we're going to hit enter, and we're going to do the square root of 2 divided by 2, and same decimal. That's how we would check something like that. Is that okay with everybody? This is very interesting how this is like unfolding. I'm very curious to see what happens. Okay, go ahead.
I had a question about how you got, I understand how you got 390 to 30, but it was just getting 30 to square root of 3.
So that was the right triangle. Remember last time we did a right triangle? If we have 30 degrees, we said, how did we do it last time? Oh, remember we did the equilateral triangle? That was a whole discussion last time. So right now, I know that's a little bit convoluted to remember those numbers. Just hold out until the next section and I'll give you a shortcut for remembering this stuff. So we talked about this last time. Remember we had the 30, 60, 90 triangle last time? We did the two isosceles triangles, so we made an equilateral triangle. The hypotenuse was 2 on all of them, so then that means that shorter leg, we cut it in half, was a 1. So we had the 1, 2. The missing leg was root 3. That was all the discussion last time. Forget about all that, all right? That was just for introduction purposes. Let's get to the next section, and I'll give you a nice, nifty shortcut to remember these figures. Okay, yeah. So let's get there, and then we'll see it. Let's keep those. We need to duplicate this. On this one, hang tight. I want to get rid of this. I need to get rid of that. I need to get rid of this. And then on the next one, not that one, or actually I just need to switch these around. Boom, I think we're good to go. And then this one, I need to get rid of my annotations. Delete. And let's play it from current slide. Okay, there was a question? It's trig. I wouldn't go that far. What class did you take in high school? It might be, because this is pre-calculus. Yeah. So you probably should have been in a calculus course. But I don't know if they... Yeah, so we'll see. Let's keep the rhythm going, because I'm not sure exactly how far you guys go or what details. So this is just a smooth transition for you, right? Because I kind of went through the same thing when I went from high school to college. When I was in high school, I took calculus. They started me off in calculus again. That's just to make sure going from one institution to another, we hit the marks. You more than likely probably could have started in calculus, but you know, I don't know if it's too late. This is what, the end of week 2? From pre-cal? That might be the case. So you just have to just go ahead and do your best and keep it moving. It's unfortunate that you're wasting your time and money, but sometimes that is the case. Like that, it does work out like that. So you just have to try to help your classmates and things. Okay, just do your best. Let's keep it going. So I think we did all this. So they sketched it first, right? They did the 30 degrees. So 390 was the same as 30. And then like the same discussion last time, we said root 3 over 2. Now we have a shortcut for this. We'll talk about it when it comes up, but I think we got all these results. So let's kind of keep it going. Let me think about this. Yeah, so this is just talking about when we take in like the trig function of angles larger than 360, then, you know, basically just remove complete revolutions and then look at the coterminal angles. That's what this is talking about. This is just referring to the coterminal angle. So we're going to let that be. Determine the sine of trig functions of an angle in a given quadrant. Okay. I'm going to let you go through this on your own. We're just going to work it. All right. What I'm pretty much going to be playing on is that cosine is like our x and sine is our y. So I'm going to be using that notion to answer these questions. Okay. Even though we haven't officially said it and gone through some other details, but right now that's the main thing that I'm going to be using. Cosine is like my x, sine is my y. For instance, if we're in quadrant 2, is x positive or negative? X is negative and y is positive. Say we're in quadrant 3, x is, y is, so on and so on. Does that make sense? So that's the play that I'm going to be using to answer these questions. Okay, if sine is negative and cosine is positive, is sine our x or is that our y? So if our y is negative and our x is positive, what quadrant are we in? Does that make sense? Is that right? Does that make sense? We should be in quadrant 4. So it says if our y is negative, our x is positive, what quadrant are we going to be in? We said 4. So therefore, theta lies in quadrant 4. The last slide? This is all on Moodle. This one? Huh? Tan is what over what again? So once you have sine and cosine, let's see it in action. Let's see it in action. She's in another one. Totally distracted. Okay. It's like I get out of this with people for like a day and it's just like everything changes. I was like, what is going on? Like everything is moving so fast. I can't keep up. I refuse to keep up. It's like now I'm kind of not keeping up intentionally just to be facetious. Like energetically, that's how I feel. Anyway, okay, we just did that one, so let's keep it going. Let's do another one. What's the time? I know we're kind of... I think I'm going, for you all, I think I might do some videos outside of class so that way we don't have to rush, but we can still... So you're going to have to watch the videos outside of class and take notes as if you're in class. I don't want to rush, but we got to keep our pace and rhythm, and 2 hours is nowhere near enough. Like if we did 3, then that might be enough. Okay, but let's keep going. So now we want to look at finding the reference angle of an angle. So reference angle, long story short, is the positive distance away from the x-axis that angle is. For instance, if we're looking at part A, what quadrant is our terminal side in? What quadrant is that? Quadrant 2, right? So the reference angle is the double hyphen you see. So how far the angle is from the x-axis? Right? So we're really only considering when it's either on the left or the right, right? When it's on the left, we use the negative x-axis. When it's on the right, we use the positive x-axis. So reference angle is how far away from the x-axis that side is. right? For instance, say we're doing part C. What quadrant is that? Quadrant 4. So the reference angle is the double arrow part, the double curved part, right? So we're using the positive x-axis because it's on the right side of the y-axis. So we're going to look at it in regards to the positive x-axis. Once we have the reference angle, it drastically simplifies everything. We're gonna see this in action. Okay, find the reference angle. So now 150. If we're at 150 degrees, what quadrant are we in? So if we're in quadrant 2, how far away from the x-axis are we in quadrant 2? If we're at 150. So if we're in quadrant 2, what's the x-axis? What's the angle? What angle is this straight edge over here? If we do a full half rotation, what's this? 180, right? So 150 is how far from 180? 30, right? What do we do? Subtract. So we say 180 minus 150. So the reference angle there is 30 degrees. Let me see. Yeah, 30 degrees. That's exactly what we want. You see how, is that okay? Okay. So now if this is 0, the positive x, and we go negative 45 degrees, what quadrant are we in? Quadrant 4. So if we go negative 45 degrees, how far away from the x-axis are we? 40. Does that make sense? 45 degrees. So the reference angle for B is 45 degrees. Does that make sense? Okay. Now see, 9 pi over 4. I think I already know the answer, but I'm going to let it be. No, actually, there's a shortcut for that one too. I still want to wait till we get to the unit circle before I talk about it. So for right now, let's go ahead and convert it to degrees, right? So did we do this one already though? What was this degree? This was 405. Now, if we're at 405 degrees, what's that? What angle is that? If we go 405 degrees, what angle is that really? What's the coterminal angle? It's really, like we did it, it's really just, if we do 405 degrees, what's the reference angle? 45 degrees, right? Remember, we just did that one.
45, it's 45.
Did we just do that one, right? Yeah, that sounds like.
I thought you said 450.
I did. I said 405, 405. So if we do 405, we say 405 minus 360, right? Hey Siri, what's 405 minus 360?
405 minus 360 is 45.
So that reference angle, the coterminal angle is 45 degrees, which coincidentally is also our reference angle. So we're in quadrant 1. I thought it was going to be straightforward because we had just done it, but that's okay. So that one, again, 45 degrees. So I'm going to let that be. And then 45 degrees, we'll put it back in radians. Since we started in radians, we convert it back to radians. So then 45, when you convert to radians, is just pi over 4. Okay, let's let that be for now. Oh, the last one. Was it negative 5 pi over 6? Let's convert that to degrees. All right. So then 150. So that's really a negative 150 degrees. So if we're at negative 150, so if this is 0, do we go counterclockwise or clockwise? So then what is this? This is negative what? 90. This is negative 180. So then negative 150, what quadrant are we in? 3. If we're at negative 150 in quadrant 3, how far away from the x-axis are we? Yeah, 30 is correct, right? Because it's 180 minus 150 is 30 degrees. So that reference angle is 30 degrees. And now, if we convert 30 degrees back to radians, pi over 6. So notice we got a quadrant 3. All right, we said we were 30 degrees away, then we put it back into radians. Now we have a way of doing this strictly in radians. I'll talk about that when we get to the unit circle. The unit circle, I think, clears a lot of this up, in my opinion. I would like to do the unit circle today. I'm going to I don't know that I can go fast with this. Use the reference angle to find exact values. Okay. I'm going to let this be, I'll do a couple of these. Now, 135 degrees. What quadrant are we in? Quadrant 2. What's the reference angle? When we say reference angle, we're asking how far away from the x-axis are we?
45 degrees.
Okay, so this is really, so for part A, I don't want to do red. Clear the ink. I like blue. Blue is okay with me. Great, I say great minds like blue. I'm just saying something just to say something nice. Okay, so this is really the same as cosine of 45 degrees in what quadrant? What quadrant did we say? Quadrant 2, right? So what's cosine of 45 degrees?
Cosine of 45 degrees.
Mm-hmm. I think we said that was root 2 over 2. I'll give you the shortcut momentarily. Now, is cosine, is that our x or our y? Cosine is our x. So is x positive or negative in quadrant 2?
Positive.
X is negative in quadrant 2, right? So this result has to be negative. Okay.
The x is negative and the y is positive.
Okay. Yes. Yeah. Okay. So then B, tan, 600. What's the coterminal angle? How many revolutions did we do? 1. So what's the remainder? Hey Siri, how are we going to find the remainder? Okay. Hey Siri, what's 600 minus 360?
600 minus 360 is 240.
Okay. Now, if that's 240, what quadrant are we in? So let's see. This is 0. What's the next one? This is, what is this one up here? How many angles? How many degrees? 90. What's this one over here? What's the bottom one? So we are in quadrant. So we're in quadrant 3. So what's the reference angle? How far away from the x-axis are we in quadrant 3? 60, right? 60. Because here's the 180. 240 minus 180 is 60. So this is really tan of 60 degrees in what quadrant? What, 3? Is that right? Go ahead. Mm-hmm. The x-axis. So you want the distance from the what is it called? Complementary angle. How far away that angle is from the x-axis, right? So here's the x-axis. Here's the origin, right? If we're over here, we're talking about this angle here. If we're coming this way, we're talking about this angle over here, right? Okay, let's do each quadrant. So if this is the origin. Say my elbow is the origin. Say we have an angle, a terminal angle in quadrant 1, right? So we're talking about, our reference angle is over here. So we're just going to say whatever our angle is, usually just take that angle as it is in quadrant 1. Does that make sense? Now say we have, I don't know, like 150. We're in quadrant 2. So the reference angle, we got to say 180 minus 150. You see what I'm saying? Quadrant 3, we still use the 180 because we got to do, 270 is the y-axis. We want to do the x-axis, right? So if we're over here in quadrant 3, say we're at, I don't know, say we're at 250, right? What's the reference angle? We would have to say the 250 minus the 180, right? So we either are using 0 or we're using 180, but it's all focused or centered around the x-axis. If we're in quadrant 4, say the angle is 300, what's that reference angle? How far away from the x-axis are we? So we say 360 minus 300 is what? 60, right? So we're always using the x-axis. Let's try to keep working it, and we'll hopefully it'll show. 60 degrees. So let's use the sine and cosine. What was sine of 60? So that was root 3 over 2. Cosine of 60 was 1 over 2. So then that result, yeah, it was just the square root of 3. So if this is sine over cosine, and we're in quadrant 3, sine is our y, so both x and y are negative in quadrant 3, so negative over negative is positive. So one shortcut for tan is really just the slope. Tan is the slope. So is our, like, say we're in quadrant 1, the slope made from an angle with quadrant 1 and the origin, is that going to be positive or negative? So say we have a line like this, is that going to be positive or negative? That's a positive slope. Say we have a line passing through quadrant 2, is that going to have a positive slope or a negative slope? Negative slope, right? So tan is really just a slope. If we're in quadrant 3, is that going to have a positive slope or a negative slope? Positive, because double negative is positive. You see what I'm saying? And then quadrant 4, that's going to have a negative slope, right? So that means tan is negative in that quadrant. So tan is really just a slope. That's one of the shortcuts. I'm going to do 17 pi over 6 in degrees. So let's just do it quickly here. 17 pi over 6 times what? 180 over pi. So 510? Is that right? Is that right? See? 17 pi over 6? Mm-hmm. Is 510 right? Okay. So we're really doing sine, we're doing sine of 510 degrees. So sine of 510, what's the coterminal angle? Yeah. Yeah, keep going. Yeah. What's 180 divided by 6? 30. What's 30 times 17? Okay. Okay. I know it doesn't look like a 6, but when you crunch the numbers, it should work out. Okay. So 510. What's that coterminal angle? How many? So we got to subtract 360, right? Hey Siri, what's 510 minus 360?
510
So that's
minus
150.
360 is 150.
So this is the same as sine of 150 degrees. Now that we have that 150, what quadrant are we in? 1, 2, 3, or 4? We're in quadrant 2. How far away from the x-axis are we? 30. So this is really sine of 30 degrees in quadrant 2. So what's sine of 30 again?
No, 1/2.
No, I think you got it right. 1, 2, 3, 1, 2. No, 1, 2, 3, 1. Yeah, you're right. Sine, x, y, 1, 2, 3, 1. That's a half, right? That's a half. I haven't given you the shortcut just yet. And then, so sine, is that our x or our y? That's our, and then is y positive or negative in quadrant 2? Positive is correct. So this one should be a positive 1/2. Let's try one more. Pi over 3, let's convert that. 60. So this is really the same as cosine of negative 60 degrees. What quadrant are we in?
The first one.
If it's negative 60.
Oh, freak. The second one. We gotta be in the second one. It's negative 60.
If this is 0, if we go negative, do I go up first or do I go down first?
Down.
We go down first. So what quadrant are we in?
Either 3 or 4.
We're in quadrant 4.
We're in quadrant 4.
We're in quadrant 4. Okay. So if we're at negative 60, the reference angle was 60 degrees away from the x-axis in quadrant 4. So this is the same as cosine of 60 degrees in quadrant 4. So the quadrant tells us whether it's positive or negative. That's the point of quadrant. Let's go ahead and wrap this up. 60 cosine 1. Okay, what's the cosine of 60? Cosine of 60? You sure about that?
Negative 0.952.
Yeah, cosine of 60 is 1/2, right? Okay. So the result there is a half. Cosine is our x. So if we're in quadrant 4, is x positive or negative in quadrant 4? So the final result should be positive. We should be able to check these in a calculator, right? So I'm going to do the following. I'm just going to take a screenshot of this for my own personal thing. Let me see if I can just do the following. Let me hit done. Let me actually go like this. Share. Don't want that. I'm going to go like this. I just want to do a new note. I want to import. Done. Give me just a moment. Let's go here. Okay. Where is it? Did I put? There it is. So I just want to look at this. So this is what we were just working on. And I want to have that next to this one. Just like that is fine. Boom. Now we can kind of see these together. Okay. All right, so let's just check these really quickly. Let me go ahead and reload and refresh this. Okay, so now the first one, first we have to put the mode into what? For the first one, degrees. Okay, it's okay. Let's go ahead and do cosine of 135. What kind of, so we're gonna get some, what kind of answer should we get? Some kind of decimal. So the radians are just as an angle. So when we do the trig of an angle, we finish with a ratio, not another angle. So when we do cosine of 135, we should finish with some decimal. Should it be positive or negative? It should be a negative decimal. We got it. And then we can confirm negative root 2 over 2. We got the same thing. Let's go ahead and do B, tan of 600. We're anticipating, I think we got positive. And then we're just going to do the square root of 3 to confirm. Okay. Let's go back to radians now for the last two. The first one was sine of 17 pi over 6. We should get a half when we get it. And then let's do cosine of negative pi over 3. I think that one was also a half, right? Let's see, how do we do? Okay. So we were able to check these in a calculator and confirm our numbers. It's a little bit back and forth initially. You know, we just have to do the best we can. Time is totally getting away from us, but that's okay. We'll do the best that we can. All right, let's go back. Now, there was a question. Did it get answered? Or did it get figured out? Uh-huh.
I understand how you got, can you just link that to me again?
Okay, so for D, first we converted radians to degrees. Is that okay? So we did that conversion, and that was fine. So then negative pi over 3 is the same as negative 60 degrees. So then if we start at 0, if we do negative 60, we have to go clockwise first. So then that actually, we finish in quadrant 4. So negative 60 degrees is the same as cosine of 60 degrees, but this is in quadrant 4. So we're 60 degrees away from the x-axis in quadrant 4. So then from last time we talked about how to find cosine of 60. Again, I'll give you a shortcut for that to remember how to remember that number in a moment. But now cosine is like our x. X is positive in quadrant 4, so that's why this result was positive. Okay. So let's kind of keep working and do the best that we can, because I know it's a little bit of back and forth. I think we checked all of these. I think these were all fine. So we're going to let that be for now. Okay, so given that cosine is negative and theta, okay, if theta is between pi over 2 and pi, what quadrant are we in? What's pi over 2? Try again. That's our 90. Pi over 2 is our 90, and pi is 180, right? Because, yeah, okay. So pi over 2, so if we're between 90 and 180, what quadrant are we in? We're in quadrant 2, right? So it's saying that cosine of theta is negative, and theta is between 90 and 180, which means we're in quadrant 2. Okay? Find the exact values of the remaining trig functions. So since they gave us an expression for cosine, I'm going to use Pythagorean Theorem. We're going to use sine squared theta plus cosine squared theta should equal 1. Let me think about this. This will be, I think this is okay. Let's keep going and see where it goes. So we want to find sine. So sine squared. Cosine was what? Let's do the negative 2 over root 5. I'm going to say squared. That should equal 1. Okay. So then sine squared theta is going to be equal to 1 minus 4 over 5. Is that okay? Because if we square it, it becomes a positive 4 and it stays as 5. So then that result is 1 over 4. So if sine squared equals 1 over 4, we take the square root on both sides. So that means that sine of theta should be, what is that, a half? If we're in quadrant 2 and sine is our y, Is y positive or negative in quadrant 2? Positive. So this result should also be positive. Okay, so now we have something for, so we have sine of theta equals a half. We were given that cosine of theta was a negative 2 root 5 over 5. Are we doing this right? Nope, we didn't do it right. I found my mistake. Anybody see my mistake? Where's the mistake?
Yes.
Okay, for the sake of time, I'm
Is
just,
it the 1 minus 4 over 5?
yeah, right? I made a mistake there. So let's back it up. We got to get rid of that, this, and all of this has to go. All right, let's back it up. Okay, let's try it again. So 1 minus 4 over 5, what's the result there? 1 over 5, right? Okay. So if that's 1 over 5, okay, so when we go to take the square root on both sides, we get 1 over the square root of 5, which is root 5 over 5. Okay. And it still should be positive because signers are y, we're in quadrant 2. So y is positive in quadrant 2, so this should be positive. So sine of theta should be root 5 over 5. My indicator that something was off was the denominator. Usually the sine and cosine have the same denominator, right? So when I got that, when my first one was a half and then the second denominator was 2, I was like, wait a minute, that usually is not right. So that was my flag, my warning. So then I was like, wait, let me go back and look at my numbers, and that's how I found it. But so we're saying that sine is root 5 over 5. Cosine was given, so that's the negative 2 root 5 over 5. So that means now we should be prepared for the rest. So then tan of theta, tan is what over what again?
10 is opposite over
Sine over cosine, or opposite over adjacent is fine. But in this context, we're going to use sine over cosine. So if we do sine over cosine, what's the result?
and it's going to be just negative 2.
Close.
Wait, it's going to be, is it negative?
Okay. So remember, tan is our what again? Tan is also our slope. If we're in quadrant 2, is slope positive or negative?
Negative.
Slope is negative, right? So that's why we got a negative result there. Let's keep it going. Sine, what's the reciprocal of sine called?
Secant.
Cosecant. It's okay. So what's the result here? Keep going.
5 root 5 over 5.
Yep, if you simplify it, we'll get this, okay. What's the reciprocal of cosine? Secant.
Is it oh yeah, secant.
Just secant.
Is it negative 10 over root 5?
I think it's going to be negative root 5 over 2, right? So I'm using the initial. It says that cosine of theta was negative 2 over root 5. I flipped that one. That one, in my opinion, is easier to flip than the simplified one, the rationalized one, right? But if you got to crunch the numbers and you'll get there. If you crunch the numbers, you'll get there. Then we're going to do cotan of theta. So that's just going to be negative 2. Okay, so these are the results that we got there. We're essentially out of time. Let me see the time. We got like 30 minutes, which is not enough for the next one. Let me duplicate this. And let me go back to this one and get rid of this stuff. Delete. And then on this one, let me get rid of my annotations. Okay, so I feel like this stuff is okay. Yeah, I think we got all these results. I'm going to let that be for right now. I'm going to leave this one as an exercise. Okay, so try it on your own. If I need to go back and do a dedicated video for this one, I will. 30 minutes. I'm going to stop the stream and I'm going to go ahead and start on the next one so we can get that shortcut going. Okay.